Everyone, welcome to Master J Skills. Today we will discuss about the JVM architecture. We will see how our .class file will be processed under JVM architecture, that is Java Virtual Machine. Let's start. There are two machine-specific languages called a compiled language and interpreted language. So what is compiled language? In any programming language, the code is first compiled into the platform-specific machine code are called as a compiled language, which are of bytecodes. These bytecodes are only understood by the machines. So in any scripting language like a JavaScript, Python, it executes by the instructions of a script without compiling are called as an interpreted language. Whereas Java uses both languages, like a Java is first compiled to the bytecode which generates the .class file, and this .class file then interpreted by the JVM for the execution. So we will see how this will happen under JVM. Here the JVM acts as a runtime engine to run Java application. JVM is a part of JRE, that is Java language. In any programming language, the code is first compiled into the platform specific machine code are called as a compiled language, which are the bytecodes. These bytecodes are understood by the machine. So that's why we will be generating .java file to a .class file. Moreover, we are not generating JVM itself is a Java is a moreover we are not generating Java is generating .class file. So whereas the interpreted language in any scripting languages like JavaScript, Python, it executes by the instructions of a script directly without compiling them. Those are called as an interpreted language. Here the Java uses both languages, like a Java code is first compiled into the bytecode which generates the .class file, and this .class file then interpreted by the JVM for execution. Your JVM acts as a runtime engine to run Java application. The JVM is a part of a JRE, that is Java Runtime Environment. This we have already saw in the previous video. If you didn't, please check out in the previous video. It's very important to understand the difference between what is the difference between JDK, JRE and JVM. Java applications are called as a write once run anywhere, means the programmer can develop a Java code on any one system which can run on any Java enabled system. That is the beauty of a Java, that is called as a Java is a platform independent. When a Java file is a compiled, .java file to a .class file will be generated by the Java compiler. This .class file goes into the various steps when we run it. This is by the JVM architecture. Now let's understand how it really works by the JVM architecture. Java JVM architecture, where you can see the class loader, JVM memory and execution engine. JVM components. JVM consists of three different components called a class loader, JVM memory and execution engine. Let's see what is the role of each of these components in detail. Now let's understand what is the role of a class loader. Class loader is a subsystem used for loading the class files. It is responsible for loading, linking and initializing. So now let's understand what is the main role of a loading. The class loader reads the .class file by loading the functionality which stores the complete class file information like fully qualified class name, its parent class, interfaces, variables, modifiers, etc. It's all about the class informations will be stored under the method area by using the loading functionality of a class loader. After loading the .class file, JVM creates an object of a type class to represent the file in the heap memory. So it creates a copy of a file, it's a copy of a class file, and that will be stored under the heap memory. After class is loaded into the memory, it links the process. How it links it, that is linking a class or interface involved or combining the different elements and its dependencies of a program together, though it will link all of them together. In initialization, all static variables are assigned its values, calls the class constructors, executes the static blocks and assigning by assigning its values. So this is all about the class loader. So basically the class loader does loading, linking and initializing of a complete class in different areas. This is all about the class loader. Now let's see what is a JVM memory. JV memory holds or stores a complete class information in below areas. So the class loader responsibility is to load, link and initialize, but where and all these particular information gets stored into the JVM. So that's into the JVM memory. So JVM memory holds and stores a complete class information in below areas, that is method area, heap area, stack area, PC registration. So native method stacks. Method area is a shared resource as one and only one method area per JVM. Class level informations like class name, parent class name, methods, variables are stored in the method area. Before Java 8, static variables were stored into the method area. After JVM 8, after Java 8, static variables are stored into the heap area. All objects informations are stored into the heap area. Heap area is also a shared resource where method area and heap area both are a shared resource. Now let's see what is the stack area contents. For every thread, JVM creates a one runtime stack. Every block of this stack is called as a activation stack frame, which stores method calls. Local variables of that method are stored in its corresponding frames. After thread terminates, its stack frame will be destroyed by the JVM. So stack frame is not a shared resource. It is specific to a particular thread. Each thread has a separate PC registration. The address of a current execution instructions of a thread, which stores address of a current execution instructions of a thread. So what does the native method stack? It stores a native method information. For every thread, a separate native stack is created. So here the method, heap, area are shared resources, whereas a stack, PC registration and native methods are not a shared resources. So this is all about the JVM memory. So it contains 5 different areas, that is method area, heap area, stack area and PC registration and native methods. Now let's see what is the execution engine. Execution engine executes the .class file, that is a bytecode of a class. It executes the bytecodes line by line, read the data and information of a specific class present in the various memory areas and executes the instruction. Execution engine has 3 different parts, that is an interpreter, just in time, that is a JIT, and garbage collection. Interpreter interprets the bytecode line by line and then executes. It just reads line by line and then executes. Just in time compiles the entire bytecode and changes it to a runtime code. So whenever the interpreter says a repeated method calls, the git, so JIT provides the direct runtime code for that part. So what does the garbage collector do? It destroys the dereferenced objects. So this is a role of execution engine. Java engine is responsible to read the .class file and execute from different parts of a JVM memory. Hope you understood about this runtime engine. Now let's see what is Java native interface, that is JNI. It is an interface which interacts with the native methods libraries and provides the native method libraries like C, C++, etc. for executing. It enables JVM to call a C and C++ libraries and to be called by the C and C++ libraries, which may be a specific. It just interacts over the other native libraries of a C and C++. That's all about the Java native interface. It acts as. Now let's see what is a native method libraries. The collections of native libraries C, C++ required by the execution engine. So whatever, we will be having some dependencies on the C and C++. At that time, we will be including those libraries into our application. In that case, if a Java finds any native libraries, then that will be hold under the native method libraries. So that's all about the JVM architecture. Hope you all understood about it. And if you have any doubts, please drop in the comment box. I'm happy to answer all of your queries. And please support by subscribing to my channel. And if you really like this video, give a thumbs up and share with your friends.